Okay, here's another problem from the slides. We have this circuit. We're going to redraw it, and then we're going to calculate the equivalent resistance, and we're going to fill in this table. So we're going to calculate voltages and currents. Again, I suggest you try to go through this yourself and watch if you can't figure things out. Okay, so we're going to redraw the circuit in the usual way. Change my colors. So I've got 200, and now I've got 600, 900, and 1.8, 1,800 ohms. So these are all in parallel. So I'm actually going to redraw it like this. And then I have the 400 at the bottom. So this is going to be 200, R1. This is going to be R2, R3, and R4. And this is going to be R5 and 400. So the first thing I want to do is I want to combine my 2, 3, and 4. So I'm going to redraw this. Oh, and I forgot to put in the 9 volts here. 9 volts. All right, so I'm going to redraw this as one resistor, second resistor, and a third resistor. 9 volts. And so this is going to be my R1, again 200 ohms, and then R234. And this is R5. And this is 400. So we need to figure out the equivalent resistance for R234. And we can do that by just using the equation for three resistors in parallel. So R234 is equal to 1 over R2 plus 1 over R3 plus 1 over R4. And so that's going to equal 1 over 600 plus 1 over 900 plus 1 over 1800. I can find a common denominator, so it's going to be 1800. And I'm going to have 3, right? I have to multiply this by 3 to convert this to a denominator of 1800 plus 2 to convert that to a denominator of 1800 plus 1. So I'm going to get 6 over 1800. And so that then is 1 over 300. So that means that, so 1 over R23 is 1. So I can see here that my R234 is 300. And so there I have my voltage divider, nice and easy. So now I'm going to find the REQ of the whole thing is going to be to add them together. So R1 plus R234 plus R5. And so that is equal to 200 plus 300 plus 400. And that's equal to 900 ohms. So R equivalent is 900 ohms. So I have now this circuit where this is 900 ohms and this is 9 volts. So I can calculate the current. And so the current, if I look back at my circuit, my first circuit here, the current is going to be the same of the total current for R1 and for R5. So I can calculate those currents. So R1 or I1 is equal to I5, and that's equal to the voltage divided by REQ. So 9 volts divided by 900 ohms. So I1 equals I5 is equal to 0.001 amps. So I can plug that into my table. So I'm going to call this milliamps, my units, milliamps, and this is going to be 1 milliamp for 1 and 1 milliamp for 5. Now I can also calculate the voltage for R1 and R5 just by V1 is going to be equal to I1 times R1, and R1 is 200. So I'm going to have 0.001 amps times 200 ohms, and that's equal to 2 volts. So in my table, I'm going to have 2 volts here. Call this volts. For R5, I'm going to have double that. So V5 is equal to I5, which is the same as I1 times R5. So that's 0.001 times 400. And that gives me 4 volts. So open my table, 4 volts. So the harder ones are the ones in the middle. So we know that if we're using 2 volts and 4 volts out of our 9 volts, then what's left is that 6 volts. We have 3 volts left. So right here, we're dropping 2 volts. Here, we're dropping 4 volts. So to make up 9, this has got to be 3 volts. Right? So if we drop 3 volts across R2, R3, and R4, then that's our answer for our table. So R2 is 3 volts, R3 is 3 volts, and R4 is 3 volts. Now the current is going to be a little bit different. So the current is going to depend on our resistance values. So let's calculate the current of I2 is going to equal V2 over R2. And so that's going to be 3 volts over 600 ohms. And that's going to be 0.0005 amps. I3 is going to be V3 over R3, and that's going to be 3 volts over 0.0, sorry, let's delete that. Get my eraser. Over 900 ohms. And I4 is going to be V4 over R4. And that's going to be 3 volts over 1800 ohms. And so this is going to be 1/3 of a milliamp, so 0.000333. And this is going to be 1/6, so 0.000. And if we're not sure about 1/6, let's just use MATLAB. And we got here, let's see, we can pick our numbers and just do 1 divided by 6.1667. I can go back. So 0.000167 amps. So I can fill that in here. So I'm going to have 5 for 2. I'm going to have 0.3. And I'm going to have 0.2. And so these should add up. So I have 0.5 here. So 0.5 plus 0.3 plus 0.2 gives me 1. And so that just shows that when my current goes in here, let's see if I make this red. So my current comes in as 1 milliamp and is split between these resistors, and the ratio depends on the resistance. And so I would expect the higher current to be going through R2 because R2 is a 600 ohm resistor, and a much smaller current to be going through the 1800 ohm resistor. And that's what my calculations bear out.